I know for some of you it's been a minute since you had to graph something, so let's just go over this just real quick so we can talk a little bit about how to graph things to start with. So this is your x-axis. Let's make it a little smaller. Oops, not 20. This is your x-axis. This is your y-axis. And so if you wanted to graph point number A, let's give this thing a color. Point number A, you would go over on the x-axis, you would go -6 and then up 1, 2, 3. So this is where your A would be. If you wanted to graph E, you would go over 3 along the x and up 4. So that would be here. If you wanted to graph I, would be over 7 and then down 2. Now, we did talk about this before. When we talked about it in the lab, we talked about what the dependent variable was and what the independent variable was. And the dependent variable, that's the one that depends on the experiment, that's the outcome. And the independent variable, that's the one that's part of the setup. So the independent one is part of the setup. And traditionally, we graph the independent variable on the x-axis. And the dependent variable, that's the outcome. It depends on the experiment. That's what you measure. And that's traditionally on the y-axis. So if I'm telling you I have a chart, can we make a line? How do we make a line? Let's make a line. So if we have a chart where we say this is the time or the generation, and this is the survivors, and you would put the numbers 1, 2, 3, 4, 5, 6 over here, and then you'd have survivors in generation 1. You'd have, I don't know, you'd start out with 10. So in the first hour, you'd start out with 10 survivors. And then you'd have 8 left. You'd have 7, 6, 2, 1. You would mark the time on the x-axis and the survivors on the y-axis. So you would set this up as, that would be 1, 10. The next one would be 2, 8. Next one would be 3, 7, 4, 6, 5, 2, and 6, 1. So if you wanted to graph this now, you would start out with, we're going to give this a color. What do we not have yet? Purple. So for graphing survivors over time, you'd go 1 and up 10. That would be here. 2, you'd be at 8. 3, you'd be at 7. 4, you'd be at 6. 5, you'd be at 2. And 6, you'd be at 1. And then if you wanted to graph this curve would look like this. Okay? This is graphing in general. Now, let's talk semi-log paper. The first thing you notice when you look at semi-log paper is that it's kind of funny looking, right? This is your regular linear path. This is what linear paper looks like. And this is semi-log paper. Now, in semi-log paper, this part here is still linear. That's why it's called semi. This here is the log part. And so the reason why we have semi-log paper is because sometimes we need to graph things that may look something like this. So let's imagine for a moment you wanted to graph a sequence that's 1, 2, 2, 10. Well, let's do 2, 5. Well, actually, let's do 2, 4. 3, 8. We're just doubling the second number, right? 4, 16. 5, 32. And you get these kinds of sequences a lot when we look, for example, at bacterial reproduction. So let's try to graph this on the graph paper that we had already, that we're already familiar with, right? So we're going to go in there and let's do this with red. So 1, 2 is there. 2, 4 is there. 3, 8 is there. 4, 16. Well, Houston, it's like here somewhere, right? Somewhere over there. And we don't have enough room to actually put this in there. So the question is, how do you graph this? And the answer is semi-log paper. So the first thing you're going to have to figure out when you're looking at semi-log paper is you're going to have to look at how many cycles there are. So each semi-log paper has a certain number of cycles. And cycles are the things, usually it's easier to look from far, far away to see what the cycle is. So if you're looking from far, far away, you can see that there's like 3 repeating things here, right? Looks like there's this one kind of looks like this one, kind of looks like this one. So if you took this section down here and you'd copy paste it 3 times, you'd get that, right? All right. So when you label these, again, like I said before, this here is linear. So this is your 0, this is your 1, this is your 2, 3, 4, 5, 6, 7, 8, 9, 10. The trick's gonna be, what is the label going to be on the log side? And the thing on the log side is from here to here, it's always a multiple of 10 because it's a log. So if this is the 1, then this is a 10, this is 100, and this is 1,000. So you can already tell that the amount of space that you need, about like this, here you only got to, well, you got to 20, but here you get to 100. So let's see how you graph this, right? So here you go. This is your x-axis, just like before. Down here is your x-axis. And up here is your y-axis. Oops. Well, if you could straight y-axis would be a beautiful thing, but not today. Okay, so your first one, let's go give it a different color. Your 1, 2 is going to be 1 over and 2 up. Now the question is, where is the 2? When you're looking at these, there are 1, 2, 3, 5, 6, 7, 8, 9 lines. And that's very convenient because your 2 is here, your 3 is here, your 4 is here, your 5 is here, 6, 7, 8, 9, and then 10. One of the things you always have to keep in mind, and students get this wrong a lot, is the lowest number is not a 0, it's a 1, because the numbers don't work out if you don't have a 1. So, all right, 1, 2. So you go over 1, and then you go up to the 2, and that's where your first dot is. Let's make the second dot a different color. So your 2, 4, you go 2 on the x-axis and up to 4. So 1, 2, 3. I got it wrong. Did you see that? 1, 2, 3, 4. And this is one of the reasons why I want you to label the graph first on the outside, so that when if you get to the 5 and you really only need to go to the 4, then you see that it's wrong. So 2, 4, 3, 8. Change colors again. 3, 8 is going to be 1, 2, 3, and there's 5, 6, 7, 8. So these are your first 3 lines right there. These are your first. Now 4, 16. How are you getting? You got to go above 10. So let's first figure out what the numbers are right here. So if this is a 10 and you got to go to 10 to 100, then this here is a 20. 30, 40, 50, 60, 70, 80, 90, and 100. So 20, 30, 40, 50. Here's our 50. Let's just mark that up there. Okay. Now our next dot is going to be 416. Let's make this one purple. So you're going over 2, 3, 4 and up 16. And 16 is going to be somewhere between 10 and 20, right? So it's going to be somewhere there. It's actually not going to be exactly in the middle. because as you see, the 5 is about, 2/3 up. So the 6 is going to be a little beyond 2/3 up. Then next one is 532. So you're going over 5. This is your 20, 30, and 32 is just above that. Let's go make that a little bigger so you can actually see it. And then last but not least, we go to 664, 6. There's 50, 60, and 64 is going to be about there. Something like that. Now, as lo and behold, you didn't run out of room yet, right? You still have places to go. So if you wanted to say 7 and 128, which is the next doubling, we just have to figure out what the next set of what the next set of labels is, right? If this is 100 and this is 1,000, then this would have to be 200, 300, 400, 500. So let's make mark the 500 again. 600, 700, 800, 900. So the 6 was 64. Let's go to the next one. Actually, let's give it a different color again. 7, 128, 7, 100, and 128 is going to be like here, right? It's not going to be very far in. And now when you try to combine these, when you try to graph these together, one of the things you're going to notice is, apart from the fact that I don't know how to graph anything and that I don't have a ruler, this is actually very close to a straight line. Now, if I did this perfectly, it would be a straight line. So then what you can do from there, because now this is a straight line, you can then take the straight line and you can extend it. And with that, you can then estimate what the next number is going to be. So 7 is 128. 8 is going to be something like 200 and something, right, if this were straight.